Good day, my name is Daniel Olubumo. I'll be presenting today to you cattle identification, the history of nose prints approach in brief. My affiliation is Department of Computer and Information Systems, Robert Morris University, Moontown, Pennsylvania, United States. Introduction is the advancement in technology has greatly evolved how animals such as cattle are identified. Classically, cattle are identified by any of the following methods, namely branding, paint branding, tagging, ear notching, tattooing, paint biometric nose print, radio frequency identification, and biometric methods. However, these identification methods are not completely robust and reliable, making the need to advance the methods a necessity. Peterson in 1922 proposed cattle biometrics and identification solution by suggesting a permanent cattle identification method based on nose print principles widely accepted today. This principle was built upon by today's animal biometric researchers. Objectives: to trace the history of cattle identification methods from the classical methods to the modern day methods, to present Patterson nose print method as an improvement on classical animal identification methods. Thirdly, to present the modern day methods as an improvement on the Patterson nose print method for animal identification. Lastly, to reveal the state of the art as next level for precision livestock farming. We have three methods, the two methods earlier mentioned: classical cattle identification method, which are branding, the first one, tagging, ear notching, tattooing, radio frequency identification, nose printing, and so on. That's what shows here in figure 1, where you see the cattle being branded with different identification methods. The second methodology, Patterson nose print method as an improvement on classical animal identification methods. Tests with various papers, tests with ink, Patterson's method of print identification, Patterson's experiment on the influence of age on animals' pattern. Figure 2a shows the nose print of Jersey cow herd number 124 owned by University of Minnesota. Figure 2b shows nose print of Jersey cow head number 113 owned by University of Minnesota. Figure 2c shows the nose print of Jersey cow head number 107 owned by University of Minnesota. This is by Patterson in 1922. The last methodology, which is the state-of-the-art method as improvement on Patterson animal identification method. Instance semantic segmentation, convolutional neural networks, CNNs, fully convolutional neural networks, region-based CNN, fast regional-based CNN, faster RCNN, mask RCNN, deep mask, sharp mask, mask splitters, and so on. Figure 3 here shows cattle recognition system based on muzzle point image pattern, Kuma and Sign in 2019. Our results and discussions here, we found that there are different biometric methods of animal identification like body pattern imaging, Bello et al. 2020a, muzzle point extraction, Bello et al. 2020b, facial imaging, Kai and Lai 2013, DNA profiling, Marchand 2002, iris scanning and retina image, Marchand 2002. There is less than 1 in a trillion possibilities that two individual animals will have the same instance, in happenstance have identical 30 SNP loci genotypes, Evans and Van Enenama 2005. Injury and infection are the primary factors that can change or destabilize the unique feature characteristics of the animal iris pattern. This is the reason why it is not advisable to carry out the operation on a young animal until they are several months old. Marchand 2002. Convolutional neural networks and deep learning based cattle identification applications are proving that great advancement has been attained in this area of research, although with room for improvement. The indoor monitoring or identification of livestock is not as difficult as monitoring the outdoor livestock. Reason for the introduction of real-time technology application to handle the task. In conclusion, this paper has presented a brief history of nose print for cattle identification. Patterson was the first published paper to address animal biometrics and identification problem by suggesting a permanent cattle identification method based on nose print principles widely accepted today. Among the classical methods reviewed, RFID and biometric methods performed better with their limitations, prompted for the introduction of convolutional neural networks and deep learning in handling livestock identification either indoor or outdoor. Among the real-time methods found in literature, there is a problem with animal detection and recognition due to the occlusion and non-linear movement of outdoor animals. Therefore, for animals like cattle to be recognized and identified in real time, an algorithm that is invariant to occlusion and non-linear movement of the animal is needed irrespective of the similarity in color of the target and the candidate animal. Our acknowledgement goes to the School of Computer Science, University Science, Malaysia, Department of Computer and Information Systems, Robert Morris University, Moontown, Pennsylvania, in the United States of America, Institute of Research in Applicable Computing, IRAC, University of Bedfordshire in Luton, in the United Kingdom, Department of Planning, Research and Statistics, Ministry of Health in Bayelsa State. Thank you for your attention and thank you for listening.